Hello students, welcome back. The question is for 2 marks and is from GATE 2012 exam. They are saying a sender wants to send a file of size 10 raised to the power 6 bits to some destination over a network of 2 routers. Okay. So 10 raised to the power 6 bits file is split into 1000 packets, each of 1000 bits. And it is sent packet by packet. Now, this router is connected to source with the help of link L1. Similarly, here we have link L2, here we have link L3. The properties of these three links are very similar. That means each link is of 100 kilometers. The bandwidth on each link is 1 Mbps and signal speed in each link is 10 raised to the power 8 meter per second. Okay. They are saying find out what will be the sum of total transmission delay and the propagation delay required for sending the entire file. Now file has 1000 packets. Let us first find out what is TT and TP for one packet. So transmission time for one packet will be length of the packet divided by bandwidth. Length of the packet is 1000 bits. Bandwidth is given as 1 Mbps here. So 1 Mbps means 10 raised to the power 6 bits per second. Okay. This will be equal to 1 divided by 1000 seconds, which is also equal to 1 millisecond. So this is the transmission time for one packet. What does it mean? Suppose at any given time, router R2 has a packet. R2 will take 1 millisecond to put this packet onto the channel. Similarly, if source wants to send a packet, it will take 1 millisecond to put that packet onto the channel. This is the meaning of transmission time. Now let us find out propagation time. Propagation time or propagation delay is defined as distance between the two nodes divided by signal speed. So distance between any two nodes is 100 kilometers. Okay. I am converting kilometers into meters because signal speed is given in meters. So signal speed is 10 raised to the power 8 meter per second. So this is 10 raised to the power 5 divided by 10 raised to the power 8. It will also be 1 divided by 1000, which is 1 millisecond. Okay. Now transmission delay as well as propagation delay is 1 millisecond. And it is same for all of these three. That means this one, this router and this router will have same transmission delay. This link and this link and this link will have same propagation delay because their properties are same. Now let us see how much time is required by the first packet to reach this destination. See, suppose at time t is equal to 0, sender starts putting first packet onto the channel. This is the first bit. At time t is equal to 0, just now the sender has put this bit onto the channel. This bit requires 1 millisecond to reach here at this point. Okay. Because propagation delay is 1 millisecond. Propagation delay means how much time is required by one bit to travel completely through the channel. Okay. So this will happen after 1 millisecond. Now let us analyze how much time is required by the sender to put this packet onto the channel completely. That is also 1 millisecond because transmission time is 1 millisecond. So to completely transmit this packet, sender needs 1 millisecond. That means starting from time t is equal to 0, at time t is equal to 1, what will happen? This packet will completely occupy this channel like this. Okay. So TT and TP are 1 millisecond and 1 millisecond. This means that in 1 millisecond, complete channel will be occupied by a complete packet. Okay. This is what has happened in first millisecond. Okay. Now let us see what will happen in second millisecond. At ending of first millisecond or in just the beginning of second millisecond, first bit is here. This bit requires 1 millisecond to travel completely through the channel. That means at ending of second millisecond, this bit will be received by this router R1. So we can say complete packet will be received by the router R1. Okay. So this packet will be like this. It is the first packet. But will this source remain free for that entire time? No. In ending of this first millisecond only, the source will start transmitting second packet. Okay. So we are considering pipelining here. This first bit will be put onto the channel in starting of this second millisecond only. Or you can say just after the point this first millisecond ended. Now this packet will also require 1 millisecond to be transmitted. So after ending of this second millisecond, first packet reached here, second packet was completely transmitted by the source. This is the scenario. Okay. What will happen after third millisecond? In ending of third millisecond, P1 will be here, P1 has reached here, P2 will reach here, and source will completely transmit P3. That means P3 is on the channel. Now you can easily analyze that at end of 6 milliseconds, first packet will reach the destination. So P1 requires 6 milliseconds. In these 6 milliseconds only, P2 will reach here. Okay, P2 is here. Now by spending only 1 additional millisecond, the destination will receive P2 also. So second packet requires only 1 millisecond because during these 6 milliseconds only it has traveled till here. Okay. During these 6 milliseconds only, packet number 3 is with this router. P3 is here. Okay, P4 is here. P5 is here and P6 is here, like this. Packet number 7 to packet number 1000 are yet to be transmitted by this source. Anyways, you can see after this millisecond has elapsed, P2 will be received and P3 will reach here. Okay, so you can see in every millisecond, destination will keep on getting one packet. So P2 to P100. It is 1000 packets, sorry, P1000. So all of these 999 packets, they require only 1 millisecond. First packet required how much time? 6 milliseconds. What is the total time? Total time will be 6 milliseconds plus 999 milliseconds. This is how much? 1005 milliseconds. This is your answer. That means on ending of 1005th millisecond, the last packet will be received. Okay. See, the scenario will be something like this. In starting of 1003rd millisecond, this will be the scenario. Here there will be no data. Last packet is with router R2 and second last packet has already been transmitted and is occupying this channel completely. This is what happens on 1003rd millisecond. So 1 millisecond will be required by this packet to reach this destination, and in that millisecond only P1000 will reach here. So at 1004 milliseconds, this packet will reach here and all the packets starting from packet 1 to packet 999 are received, and one more additional millisecond will be required for the destination to receive the last packet. Okay, so from this time 1 millisecond means 1005 milliseconds. At this time all the packets are received, so total transmission plus total propagation delay is 1005, which is your answer. Okay, thank you very much for watching this video.